Is the NetServ team. Jay Lee from Colombia will be presenting their work. And the idea of NetServ is to take small programmable modules and place them in routers close to where the action is to enable more efficient behavior.
Morning, everyone. My name is Jay Lee, and I'm presenting to you today a large team effort with Janak, Roberto, Francescangeli, Suman, Srinivasan, Eric Liu, Michael Kester, Salman, Baset, Wonsong, and Professor Henning Schulzrinne. We also have a few industry partners, DOCOMO Eurolabs, Bell Labs, Alcatel-Lucent, and Deutsche Telekom. NetServ is NSF project is under the project Find umbrella, and we're developing. Oh, I need to click this. We're developing a framework for deploying in-network services on the next generation internet, and we aim to provide a common API for all internet nodes, routers, and end systems alike. So, what exactly is NetServ? It is an in-network service container which contains small modules which implement different network services and functionalities. And those are usually written in Java in the current form and deployed onto routers on the internet using signaling mechanism called NSYS. NSYS stands for next step in signaling. And this might sound familiar to some of you who are either part of or have witnessed the active networking effort in the late 90s. And that is because we propose the same vision. And in fact, what we're trying to do is to revive that vision using the current technology available today. This is why sometimes NetServ is called Active Networking 2.0. I'm going to go through briefly the NetServ node architecture. At the center, you see this green box here, NetServ controller, which controls various parts of NetServ node. In particular, it controls the service containers, which host modules written in Java that implement specific service functionality. And those modules can operate in two modes. They can simply be standalone network service, listening on TCP socket, providing network server, just as a regular web server or any content server does. Those are depicted here. These two little circles depict such modules, and they communicate with the outside world using standard networking stack. Or if the NetServ node is a router, you could have these modules depicted in here sit in the packet path. So this arrow here, the blue arrow coming in, goes through these modules, visiting these modules, and comes out, represent the packet path. And these modules are free to do what they want to the packet, either inspect them, monitor them, or even process them. Lastly, these two orange boxes represent the signaling daemons implementing the NSYS signaling protocol. And they are the ones who takes the signaling command from outside to install a module to the NetServ node or remove it or querying the capability of this node. So we are going to demonstrate a couple of applications written for NetServ. The first is called Active CDN. Active CDN implements a CDN functionality. CDN stands for Content Distribution Network. And the prime example of that is Akamai. Everybody knows Akamai, used by many businesses and content providers worldwide to reduce the load on their server by distributing the content towards many nodes at the edge of the network. We built this topology on Genie. At the center here in Kansas, there's our content server. It's an Internet 2 location. And around that server, we have three sites: University of Utah, Clemson University, and Genie Project Office, GPO, providing us with the routers. So those are where we install NetServ capable routers. On each router, we installed 2 client machines represented as the user icon here. And the user machines are actually on the same site as each of these routers, but for display purpose, we drew them a little apart from the router. So what we're going to do is 2 users from Utah and Clemson will make a video request to the server. So the screen on the right side, on the left there, represent Utah user, and this is the Clemson user. And they're watching video. And as you see in the diagram, it's a standard web server operation. You request something to the server and get streamed to the user. And you notice that this little bubble indicates that the server, upon receiving the request from a user, has installed a NetServ module into these routers so that the next time the user requests the same video, it'll get served by these routers. It gets redirected to the edge router close to the user, gets served from here. So you see the same video, but they are being served by the router. Now, this is a standard CDN functionality. There's nothing new about this. So this is what CDN does to reduce reduce the load on the server by pushing the content towards the edge. Now, we have these NetServ modules installed on these routers, and they're a piece of code that's running on behalf of the server. So we can do some localized processing for these servers. So let's see what happened when, let's see what happens when the 3rd user requests the video. So now we put a little watermark on this video. It says NetServ rocks, and that's something we'd like to say, but the point is that the content provider is full control of the module. They can do whatever they want. Can do insert advertisement or localized content, in which case we're seeing here. Here we put a little weather information. In Clemson, it's raining likely, and in Utah, I guess it's a little better, sunny. And from the timestamps here, that you see that these watermarks have been generated in real time right now. So the point we're trying to make is because these modules are developed by the content provider, specific to content provider, so that piece of code can do any functionality, can provide any functionality that the content provider would like to have on the edge routers towards the user. Another demo that we're going to do is called VoIP overload control. On the internet today, security is a big concern. And one particular type of attack that's very hard to prevent is called DDoS. DDoS stands for Distributed Denial of Service. And basically what that means is a large number of attackers send a large amount of traffic to a server with the intent of disabling and overloading the server. So in this demo, we are going to demonstrate a way to cope with this situation for a voice IP server using NetServ module. Okay? So this diagram has demonstrated this scenario in a simple way. There's an attacker sending large amount of traffic. The SIP server, by the way, SIP is a standard protocol for voice over IP communication. So SIP server, faced with that traffic, installs a NetServ module onto a router that's close to the attacker. And that module will throttle the traffic for the server on behalf of the server. And throttling the incoming traffic is not new, but what's new here is the module is dynamically installed on demand by the server, and it maintains constant contact with the server because it's a piece of code running, so it can do whatever it wants. And so thus, according to the load on the server, it can rethrottle the traffic, adjust the rate, and it can do any type of processing that is necessary. Also, in the extreme case where attacker found a new pattern of attack or something, then the SIP server can, the operators on the server side can actually develop the module on the fly and install it on demand. So let's see how this works. On this screen, you see a topology here. We have the same 3 routers, University of Utah, Clemson, and GPO. And user machines are represented as the phone icons. And the little labels underneath these machines represent the modules that are currently installed in these routers. And you actually saw that, just saw the label flashing, and the active CDN that was there just went away. That was the module that we used for the previous demonstration, and it just timed out, and it removed itself. So right now, we have net monitor modules installed. This is the module that collects real-time data and sends the data information, traffic information, to the central server so that the visualization server, which can display this visualization. So what you're seeing here, these icons floating by, represent the real-time traffic that's happening right now. And we are using these tools. This is a traffic generator. These 6 consoles there represent a traffic generator simulating the client. Okay? I think they're sending 100 calls per second right now. Now, let's imagine a scenario where these clients all of a sudden turn malicious and become attackers. And they start sending large amount of traffic. We went up to 500 calls per second. And you see that it's sending a huge amount of traffic. This represents an overload condition. So SIP server, this is too much for SIP server to handle. So what the server can do is it'll install a NetServ module onto the routers towards where the traffic is coming from. So we just saw the labels flashing. So overload module has been installed. And now the traffic coming to the server has been reduced to a manageable level. And again, the modules are in constant contact with the server. And they have a feedback loop constantly adjusting the throttling rate. So that's why you see sometimes the traffic coming to a server fluctuating a little bit. So that's a normal situation. These modules implement random early drops, so there's a certain randomness in there. If the attackers redouble their effort and send even more traffic, you see that the traffic gets large, but then the traffic coming to the server remains constant. Just to show you what would happen if we didn't have overload module, if we uninstall the overload module, this is what happens. We have a meltdown in our hands. OK, so this concludes our demo. Just to wrap it up, I'd like to say a few words about Genie and NetServ. We were able to build this topology using the newly released Genie AM API 1.0, the common API. And we built the topology across 4 sites across the United States, involving Protogenie, Planet Lab, National Lambda Rail, and Internet 2. And this kind of experiment for NetServ would be impossible without Genie. I mean, S-scale testbed is one thing, but being able to have a programmability at the router level is a great thing for NetServ. In time, we hope that NetServ can do something back for Genie. NetServ can potentially provide another way for researchers to interact with Genie nodes by providing a way to install a module to an existing node rather than allocating a brand new VM, which might be a simpler proposition for some experiments who doesn't need the full-scale VM for their experiment. So in time, maybe NetServ can be known as the Genie Lite. Thank you very much.